If f of x equals tan 2x, then f prime of pi over 6 equals what? So to solve this, we have to find the derivative. So the derivative of tangent is secant squared, and we keep the inside the same. And now we apply the chain rule. So we take the derivative of the argument, which is 2, because the derivative of 2x is 2. So that means f prime of x equals secant squared 2x. And now to find f prime of pi over 6, we plug in pi over 6 into all of our x's. Now we simplify. And now I'm going to rewrite secant as 1 over cosine. And cosine pi over 3 equals 1/2. And don't forget that cosine is squared. So that's going to be 2 times 1 over 1/4. And that's going to be 2 times 4. That's going to equal 8. So our answer is E. 76. The graph of function f is shown above. Which of the following statements about f is false? So which one of our answers right here is not true? So I'm going to start from E and then work down to A. So for the limit as x approaches a of f of x exists, we could say for sure that this is true, because if we take the graph from the left side and then the graph from the right side, they meet at the same point. So that means that E is true. Now for D, the limit as x approaches a from the right side is equal to the limit as x approaches a from the left side. And this is literally just the same as E, because if we do come from the right side, then we come from the left side, they meet at the same place. Like you take your fingers and your fingers are going to meet in the middle. And now for C, x equals a is in the domain of f. Now that's true because although it's not continuous at x equals a, the graph of f is actually defined because of this small dot right here. So that means that x equals a is in the domain of f because, you know, there's actually a value for f of a, and that's this dot right here. Now for B, f has a relative maximum at x equals a. Now we have to think about the definition of an extreme, like point of extrema. So right here, the AI overview definition, if it's a critical point, meaning that the derivative is either 0 or undefined. So maybe our derivative isn't 0, but our derivative is undefined because it's not continuous. Because for a point to be differentiable, it has to be continuous. So because it's not continuous, the derivative is undefined at this point. And the only reason why f has a relative maximum is because of this right here. Because even though it's not continuous, it's still defined, so that means you can still have a maximum at that point. Had this dot not been here, then B would have been false. Okay, now for A, I was talking about continuity, and at this point, f is not continuous, so A has to be the answer because there's a hole in the function, so that means it's not continuous. So our answer is just A. Alright, let f be the function given by f of x equals 3 to the 2x, and g be the function given by g of x. At what value of x do the graphs f and g have parallel tangent lines? So what parallel means is that both of the tangent lines have the same slope. So I'm going to take the derivative of both of the functions g of x and f of x to find the slope at any point. So the derivative of 3 times e to the 2x is 3 times e to the 2x times the derivative of this exponent. So you got to apply the chain rule. So it equals 2 times 3e to the 2x. And g prime of x is just 18x squared. So now I can just pull up Desmos and put my answers in. Now after graphing the functions, you see that they intercept at negative 0.39065, and if you round to 3 decimal places, you'll get negative 0.391. Intersection tells you when the slopes are the same. C, because they met at x equals negative 0.390 something 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 rate per second. So this is telling us that the radius of the circle is decreasing at a constant rate of 0.1 centimeters per second. So when it's telling us that, it's basically telling us that dr over dt, which is the change in r, is negative 0.1 centimeters per second. And it's negative because we're decreasing. If the radius had been increasing, it would have been positive 0.1. So now for the rest of the problem, let's see what else they use. In terms of circumference C, what is the rate of change of the area of the circle? So we have two different things here. We have circumference and we have area, and there's two different formulas for that. So our circumference formula is 2 pi r, and our area formula is pi r squared. So we have to find a way to get circumference into our area formula, and we can do that by rewriting r in terms of c. I mean c in terms of r. Actually, yeah, I don't know the term, but basically we just gotta solve for the radius where we're gonna have c. So divide both sides by 2 pi. That cancels. So r equals c over 2 pi. So this is our radius in terms of c. So now we can just take this radius and plug it into our area formula. But first, I'm going to find the derivative of area. So dA over dt, so this is the rate of change of the area, equals pi times 2r dr over dt. And after simplifying, it's just 2 pi r dr over dt. Now this is where we can just substitute everything we got. So dr over dt equals negative 0.1, and r equals c over 2 pi. So 2 pi times c over 2 pi times negative 0.1. So the 2 pi's cancel out. So it's negative 0.1 times c. And we look at our answer choices. B is going to be our answer. 79. The graphs of the derivatives of the functions f, g, and h are shown above. Which of the functions f, g, or h have a relative maximum on the open interval a to b? So when do the functions have a relative maximum? So let's just make a sign chart for each of our graphs here, so we can get an idea of which one's going to have a relative maximum. So this is going to be for f prime of x. This sign chart is going to be for g prime of x, and this sign chart is going to be for h prime of x. So for the graph of y equals f prime of x, we can see that our derivative goes from negative to positive. So this creates a relative minimum, but we can also see right here it goes from positive to negative. And at this point we're gonna have a relative maximum, because it goes from increasing to decreasing. So our function would go up and then it will go down. Now let's look at g prime of x. Our derivative goes from negative and then it goes to positive, but that's just a minimum because we're going from decreasing to increasing. Now for h prime of x, we don't even cross the x-axis at all. It's just positive. So that means that that h of x would probably just look like a function that's just increasing the entire time. So because f prime of x is the only derivative to go from positive to negative, A is our answer. The first derivative of the function f is given by f prime of x equals cosine squared x over x minus 1/5. How many critical values does f have on the open interval of 0 to 10? So a critical value, the way you find that is whenever the derivative equals 0. And we're just given the derivative already, so what we can do is just plug this into Desmos and then see whenever it crosses the x-axis. So we understand what we're looking at right here. The green curve is the graph of cosine squared x over x minus 1/5, and this purple shaded area is our window from 0 to 10. So if we look closely, there's a critical value right here because it crosses the x-axis, so that's 1. There's another one right here because it crosses again, so that's 2. And there's one more here, so that's 3. So in that entire interval, we only have 3 times where it crosses the x-axis. We only have 3 times where f prime of x crosses the x-axis, so that means we only have 3 critical values. And that means B is going to be our answer. Okay, 81. Let f be the function given by f of x equals the absolute value of x. Which of the following statements about f are true? So because this is a calculator question, I'm going to bring on my friend Desmos. I'll also get our conditions, or our statements. So for statement 1, f is continuous at x equals 0. And that is true because there's no holes, there's no asymptotes, there's no breaks in the function. So that means that 1 has to be true. Now for 2, f is differentiable at x equals 0. And we know that a function can't be differentiable if there's a sharp point. And at x equals 0, there is a really sharp point. So that means that f is not differentiable. So that means that statement 2 is false. And now for statement 3, there is an absolute minimum because let's look at our definition of extrema again. If it's a critical point, meaning that the derivative is either 0 or undefined. So the derivative is going to be undefined at this point because it's not differentiable. But even though it's not differentiable, we can still have an absolute minimum. And right here is the lowest point in the entire function. You see, like, it never gets lower than 0 because you come from the left side, it goes straight to 0. And then from the right side, you're just going to infinity. So you come from negative infinity, you go to 0, and it doesn't get lower to 0, and it just goes on and just approaches infinity. So that means that x equals 0 has to be an absolute minimum. F is a continuous function, and if f prime of x equals f of x for all real numbers x, then what is this integral? So my first step is going to be rewriting the integral in terms of capital F prime. And the reason I'm doing that is because I know what the integral of capital F prime of x is going to be. Because if I took the integral of f prime of x, all it would do is just remove this apostrophe, so I would get f of x plus c. But for f of x, it's not the same story, because if I try to the integral of this, I really can't, because I don't have that apostrophe. I don't have the fact that this is a derivative. So if I took the integral of this, I really can't. For capital F, I can't. For capital F prime, I can. So to take the integral, I'm going to have to use substitution. To take the same process like we do with our trig functions, and we set our u equal to what's in the parentheses. So our du is going to be 2 dx. So we're missing a 2, so we're going to have to put a 1/2 on the outside. So now I'm going to take the integral, which is just f of u. And I'm going to make new limits in terms of u. And to do that, you just take the limits here and plug them into u. So u of 3 equals 2 times 3 equals 6. And u of 1 equals 2 times 1 equals 2. So those are my new limits, 6 and 2. So now, using the first fundamental theorem calculus, it's f of 6 minus f of 2. And that equals 1/2 f of 6 minus 1/2 f of 2. And that's going to be option E. For 83, if a cannot equal 0, then what is the limit as x approaches a of all this fine stuff right here? So I'm first going to approach this using direct substitution. So once I plug it in, it's going to be a squared minus a squared, which is going to be 0. And I plug it into here, it's going to be a to the 4th minus a to the 4th, which is going to equal 0. So I'm going to get an indeterminate form. So that means I can use L'Hopital's rule. So I'm going to take the derivative of the top and the derivative of the bottom. So I'm going to take the derivative of top. And don't forget the notation. So the derivative of the top, x squared minus a squared equals 2x. And because a is a constant, it's just going to be 0. And now for the bottom, it's just going to be 4x cubed, and because a is a constant, it's going to be 0. So now I can cancel out an x, so it's going to be 2 over 4x squared, and I can actually simplify this further. It's going to be 1 over 2x squared. So now I plug in my a, so it's 1 over 2a squared, and now I look at my answer choices, and my answer is going to be b. Alternatively, you can do it this way. If you recognize that the bottom, we can factor out the bottom as a difference of squares, and you can absolutely do that. It would be x squared over x minus a squared over x squared minus a squared over x squared, times x squared plus a squared. These would cancel out, so you get 1 over x squared plus a squared. So then you would get 1 over a squared plus a squared, which equals 1 over 2a squared. So you end up getting the same answer. There's 2 different ways to do it. I probably would have done L'Hopital's rule, but if you'd rather factor it, then you can do that too.